Welcome to Investigation 5.3. This is extending the rules of exponents. I've already tried to make a video for this and I felt like it was very haphazardly done. So instead I am making a new video. So this is hopefully a more refined version of this video, which follows along with the sort of launch that I took you through in class. So hopefully this will help. So thinking about our exponent rules, we have, say, this situation, we have 4 to the third power times 4 to the fifth power. Well, we know 4 to the third power, we could rewrite that as 4 times 4 times 4. And 4 to the fifth power could be rewritten as 4 times 4 times 4 times 4 times 4. So 5 fours versus 3 fours. And all of that is being multiplied. So in all reality, we could just add up the number of 4s that we have and write it out as our new exponent. So we have 8 4s there, so we could rewrite this as 4 to the 8th power. So just thinking about that, in all reality, all we're doing is adding up the fact that we have 3 4s here and we have 5 4s here, so we're adding our exponents so we get that same 4 to the 8th power. So playing around with this idea, let's see if these same rules work with exponents that have fractional form. So if we have like 4 to the half or 4 to the 2/3 or something like that. So let's play around with this. So first things first, let's define what 4 to the half can look like. Another way that we can write 4 to the half is essentially saying the square root of 4. Now this is a little bit of a leap. Within exponents, we are always dividing and we're multiplying based on the exponent that we have going on. So essentially the step in between multiplying by something and dividing something could be those square roots. So 4 to the half, we can rewrite that as the square root of 4. And we know the square root of 4 is 2. So if we were to write 4 to the half, we could also just simply write 2. So knowing that substitution, let's move on to a new idea. We have this question. What is 4 to the half times 4 to the 3 halves? Well, we could start out with just the idea of this is that same exponent rule where we had a to the m times a to the n, which is essentially a to the m plus n. So adding those exponents. If we were going to do that, we could also say we have 4 to the half plus 3 halves. So we'd end up getting 4, 1/2 plus 3 halves would equal 2, so we get 4 squared, or 16. Well, another way that we can write this down just based on these exponent properties is also writing it as the square roots that they are. So 4 to the half, we can rewrite that as the square root of 4, which is also equal to 2. So we can look at those sort of things. And then we have that multiplied by 4 to the 3 halves. So we essentially have the square root of 4 cubed. So what is the square root of 4 cubed? Well, what is the cube root of 4? 4 cubed is 4 times 4, which is 16 times 4, or 64. So we have the square root of 64, and the square root of 64 is 8. So 2 times 8 is equal to 16. Exactly the same answer. So playing around with the concept of square roots, and also understanding that we have here, we don't just have 1/2, we have a half times 3 using that exponent rule, or we could write that as a half plus a half plus a half. So essentially 2 times 2 times 2, square root of, or 4 with this half as an exponent would equal 2. So playing around with those two ideas. Now, one last concept that I want to get down before we move on to our actual problem. Now, I've already said 4 raised to the half exponent is also equal to the square root of 4. And if you notice, I wrote the 2 out there because typically with the square root of 4, it's just known that it's the square root of 4. But if we were to write 8 to the 1/3, we know that the cube root has that number out in front just like this one, so that gives us sort of the concept that we can play around with the formatting. Now the next one, what if we have the very generic problem, x to the raised to the 1 over n power? Well, essentially thinking about where this 3 was placed and where the 2 was placed, we could write n being placed there over that square root and then our x in front of it. Rewrite that. So we have x, this nth root of x. We can call this the nth root. And you thought you couldn't write words without vowels. Isn't that fun? So we're going to move on to our little problem here. We have 16 to the 3 halves. It's currently in this format, this a to the m times n. And we're going to turn it into a power to a power. So we have our base of 16. And if we think of 3 halves, we could rewrite 3 halves as saying 3 times a half. Seems a little bit of a stretch, but essentially we have 3 times a half. Of course, we could write a half or 3 halves as 3 times a half. That's exactly what it is. There's 3 halves added together, which is repeated addition, and repeated addition we can write as simply multiplication. So we have 16 times 3 raised, or 16 to the third raised to the half, which could then be rewritten as 16 to the third raised to the half. So if you notice, I went from here and now I'm going to here. 16 to the third, we could rewrite that as 4,096, and then we need to take half of it, or we need to do the exponent of a half, and we know that a half as an exponent is also equal to the square root. So we have 4,096, the square root of 4,096 is 64. Let's try another method of this same problem and see if we get the same answer. So using a couple of different methods, see if we can get the same answer. Here is our next one. We have 16 to the 3 halves, and this time we're going to use this method where we are essentially adding exponents. Now we know 16 to the 3 halves is there, and 3 halves, if we wanted to, we could rewrite that as maybe 2 halves plus 1 half, because 2 plus 1 equals 3, so we have 3 halves. 2 halves plus 1 half. 2 halves we could also rewrite as simply 1 plus a half, correct? Sure hope so. Here we go. So let's keep going. We have 16, and we're going to write 1 plus a half, or 2 halves plus a half. Keeping going with this, we are at this stage right here, and we're going to turn it into this stage. So that means we can write the same base. We're multiplying those two bases, and we're going to put the exponents in their separate locations. So we have 1 half, or 1, and we have a half. So 16 to the first power we know is just simply 16, and 16 to the half power is the square root of 16, or 4. So let's write the square root of 16, which we can rewrite as 16 times 4, and we know that 16 times 4 from the previous question is 64. So we now have the same answer given in 2 different methods, one using a power to a power property, and the other using the product of powers property. Play around with these exponent properties and the concept of taking an nth root of something, and see if you can play around through this investigation 5.3. I hope this helps, and as always, if you have any questions, please ask. Don't hesitate to text me or call me, and I will talk to you later. Bye.